So today we're going to cover Chapter 8, Section 1. We're going to be learning about similar polygons. The information that we're going to be doing in this chapter, we're going to be solving a lot of proportions. So the first thing we need to identify is finding the corresponding parts of similar polygons. Before, when we talked about congruent polygons, all the angles and all the sides in a congruent polygon were congruent. Now, when we're talking about similar polygons, the angles will be congruent, the corresponding angles. However, the corresponding sides are going to be proportional. We're going to be setting up each one of the corresponding sides into a ratio or a fraction. And we're going to make sure that all of those corresponding side ratios simplify to the same ratio. Now, all of these polygons, when you're told that they're similar, they're going to have the same shape. However, the sizes may or may not be different. Anytime you have two congruent polygons, they're also going to be similar. Most of the examples we're going to be dealing with when we're referring to similar polygons is one will be little and one will be large. Now, sometimes it will be an enlargement. It'll go from something smaller to a larger polygon, and sometimes it will get smaller, like the example here. So notice quadrilateral ABCD here is going to be similar to MNOP, and it's just a reduced version of the larger ABCD. And it's basically in this particular slide, it's just a scaled down version. Now, what if we were to have numbers on these pictures, we would need to match all of the sides, and we would get our statement of proportionality, which is what this is right here. However, the sides, and I need to add congruency marks here, all of the corresponding angles will be congruent. And just like before, when we talked about congruent figures, know that the statement they give you will tell you what matches. So for example, the little wave in between here, this is the symbol for similar. So this little wave symbol is the symbol for similar. It looks like the top of a congruency. So in order to figure out what angles are corresponding, I can use my statement. So the first letter, A, is going to match with the first letter of the second quadrilateral, which is M. So A and M would be congruent, which is this first statement. Then I can see that B is the second letter, and it's going to match with N, which is the second one. So again, I can add congruency marks. Because again, when they're similar, the angles are still congruent. It's the sides that will be proportional. Then the third letter, C, will match with the third letter, O. So I can add congruency marks here. And then finally, the last one, D and P, and I can show that D has the same marking as P, showing that these are congruent angles. Now, for the sides, we can still use the original statement, and notice the first two letters, AB, are going to be this first proportion here, or this first ratio. Then the second two letters, BC, will match with NO. And then the last two letters, CD, will match with OP. And then lastly, the AD, the beginning and the end, with the M and the P. And that would be the last ratio. Now, if my figures had numbers, and I'm going to add the numbers to it, what you look for when they want you to prove if two figures are similar is if each side length ratio simplifies to the same ratio. So let me add some numbers. Let's say you were given that AB was 6, BC 8, CD 10, and AD 8. And then I'll add numbers to this one, 3, 4, 5, 4. So now, what I want to do is make sure that when I take the lengths of these sides, so AB is 6, MN is 3, and then I need to reduce it. This is my simplified ratio. It simplifies 2 to 1. Then I'm going to do the same thing for BC. BC is 8, NO was 4, and notice it's also simplifying to the same ratio. As soon as you find a ratio that does not simplify to the one before it, then you can stop and say that the figures are not similar. Let's do the same thing with CD. I have 10 over 5, 2 to 1. And then lastly, AD, 8 over 4, and it also simplifies to the same ratio. So because they all simplify to the same ratio, I can tell that because they have congruent angles and proportional sides, these two quadrilaterals are similar. But we were told that from the beginning. So if they ask you to list all the corresponding parts, you would list the angles as being congruent, but the sides are going to be written as a statement of proportionality. Okay, so this would be for the sides, and you write them as a proportion or a statement of proportionality. Statement of proportionality is all of this. Now, if it asks you for a scale factor, then what we would need to do is figure out what did we multiply the figure on the left by to make it the figure on the right. So whenever, and this is coming up on the next slide. So when it asks you for a scale factor, what we need to do is take the figure on the right and put it over the figure on the left, those numbers. So the right numbers over the left numbers. So if I wanted a scale factor using, say, side AB and MN, I would have had to have done MN over AB, and then that would have been 3 over 6, and my scale factor was 1/2. Because what I did was I multiplied all of the numbers or all the side lengths of this figure by 1/2 to get the new scaled down figure. So it's also divide by 2, but a scale factor is always multiply. Figure, so maybe let me rephrase this. So the side length of the right figure, its number, over a side length of the left figure. So always do right over left to get the scale factor. This slide actually has the official scale factor. And if you're told that two polygons are similar, then the ratio of the corresponding sides of the two similar polygons equals the scale factor. Now, in this particular example, these are two equilateral triangles. So it really doesn't matter if I match AB with EF, it doesn't matter because they're all the same numbers. However, to get the scale factor, I have to figure out what did I multiply these numbers by to make it into the larger figure. So this is why I need to do the right over the left. So then this would simplify 2 to 1. So my scale factor is 2 because what I multiplied all of those 3's by to turn them into 6 was multiply it by 2, which is your scale factor. And the scale factor is always a simplified ratio. Okay, so for example 1, it wants us first to find the scale factor what did we multiply those sides of quadrilateral ABCD to turn it into quadrilateral MNOP? After we find that scale factor, we're going to use it to find the values of X, Y, and Z. Then once we find the values of X, Y, and Z, we can find the perimeter of that second figure, and then we can also find the ratio of the perimeters. So let's go ahead and work on finding the scale factor. And again, I can use the statement that they gave me, and I'm going to start setting up all my matches. And I'm going to set it up over right over left. So I'm going to take my first two letters, A, B, and MN. So I'm going to do MN over AB. Now, if it asks for a statement of proportionality, this is what we would be setting up. And let me go ahead and add in my variables here too. So MN is Y and AB is 12. So these are the two matches. Then BC is going to match with OP or NO. Let's do NO, BC. And NO is X and BC is 4. And then the next one will be CD with OP. And that's going to be Z over 14. And then lastly, we're going to do MP over AD. And this is going to give us our scale factor, because out of the 4 ratios I just wrote down, this is the only one that has 2 numbers. Now, if they ask you to give a statement of proportionality, this is the statement of proportionality right here. So this is a statement of proportionality. If they ask you to state what angles are congruent, you could say angle A congruent to M, angle B congruent to N, angle C congruent to O, and angle D congruent to angle P. So if it asks you to list the corresponding parts, you would list the congruent angles using this statement and also give the statement of proportionality. If you were just looking for the scale factor, then I would have just looked for this pink one, because this is going to give me my scale factor. It's the only ratio that has 2 numbers. So for the scale factor, I'm using the MP over the AD, which is 8 to 10, and I need to reduce it. It's always a simplified ratio, 4 to 5. I'm now going to use my scale factor, and I'm going to create 3 different proportions to find X, Y, and Z. So now I'm going to use my scale factor, and now to find X, I take that ratio, the NO over the BC, which was the X over 4. I'm going to cross multiply 5X, and then 4 times 4, divide by 5. Now, because this is a side length of a polygon, you're going to need to make it a mixed number or a decimal. So 5 will go into 16 3 times with 1 left over. You can either leave it a mixed number, or you can fully divide it and make it a decimal. Now to find Y, I'm going to use the red ratio, solving the proportion. So what I'm doing here is multiplying 5 times X and then 4 times 4. So the 4 times 4 is the 16. The 5 times x is the 5x. And then I have to divide. Now it's just a simple multiplication equation, and I divide both sides by 5. Now, to find y, the answer to part A is just the scale factor, and it's 4 to 5. Now, for part B, this is what I'm working on now. I'm using the scale factor that I just found in part A to find x, y, and z. So now I'm going to come down here. That was my first proportion. I'm still using the scale factor, so I'm still using 4 to 5. But now, to find y, I'm using the red ratio, which is y to 12. And again, I'm solving this by multiplying diagonally. So 5 times y gives me 5y, and then this diagonal, 4 times 12. And if it's easier for me to put it in here like this first, and then show the multiplication, and you get 48. And now I divide both sides by 5. 5 goes into 48 9 times with 3 left over. So 9 3/5. If you prefer to make it a decimal, you would finish the division and get 9.6. And now lastly, to find the value of z, I'm still using the scale factor. And then the ratio was the purple one for z. It was z over 14. Again, you're going to multiply diagonally. So 5 times z, and then 4 times 14. So here I get 5z equals 4 times 14. 4 times 14 is 56. I need to divide both sides by 5. 5 will go into 56 11 times with 1 left over. So 11 1/5, or 11.2. So these are all the 3 answers for part B. It had asked you to find the value of x.
Zachary Verona and Kristen Sanchez, page 4 Student Services. Zachary.
Okay, so it asked you to find x, y, and z for part B. Now that I found the 3 sides of that smaller quadrilateral, now I can go back and find the perimeter. Because remember, for perimeter, you have to add up all the sides. So let me zoom in here to the picture. So I just found the value of y. Y was equal to 9 3/5, or 9.6. X was equal to 3 1/5, or 3.2. And lastly, z was equal to 11 1/5, or 11.2. So to find the perimeter of the larger one, we're going to add up the sides. 10 plus 12 plus 4 plus 14. Once I add up these 4 numbers, it adds up to be 40, so it's 40 units. For the smaller one, you can either choose to add it as fractions, so 9 3/5, 3 1/5, 11 1/5, plus 8. In this case, since they all had a common denominator, it's not that bad. So once you add them all, you would have gotten 31 and 5 over 5. And 5 over 5 is 1 whole, so 32 units on that one. If you would have preferred as a decimal, you would have been 9.6, 3.2, 11.2, and then 8, and then you would have gotten 32.0. Either way, it doesn't matter. So that would have been the perimeter of each. So this was 32 units. If it would have had inches or centimeters on the sides, then that would have been the description, but this one didn't have any description of units, so you just put the word units. Now it wants me to find the ratio of the perimeters. And again, I'm doing right over left. So for part D, the left figure was 32. The right figure was 32 and the left was 40. Notice I can divide or simplify this ratio by dividing them both by 8, and this simplifies 4 to 5. Notice it's the same answer I got for part A. So what we're going to see coming up is that the ratio of the corresponding side lengths and it doesn't matter which side length you pick to put into a ratio, as long as you're told that the polygons are similar, this ratio of the corresponding side lengths is also equal to the scale factor, which is also equal to the ratio of the perimeters. It will always be the same. And in this case, all 3 of them were 4/5. So in this particular problem, they were all 4 to 5, all 3. So for this one, it says corresponding lengths in similar polygons. So if 2 polygons are similar, then the ratio of any 2 corresponding lengths in the polygon is equal to the scale factor of the similar polygons. And this is exactly what I just wrote at the top of the last slide. So the ratio of any 2 corresponding lengths is going to be equal to the scale factor. So no matter which 2 corresponding sides you choose and then simplify that ratio, it will always equal the scale factor. However, you need to be told that the polygons are similar. Now the next example is bringing back prior knowledge. Before Christmas, we learned about special segments in triangles. One of the segments we talked about was the altitude. And another name for altitude is really the height of the triangle. So in this particular picture, they're telling us that triangle TPR, the one on the left here that I'm highlighting in blue, is similar to the triangle on the right, which is XPZ. So because these triangles are similar, I know that if I can find a pair of corresponding sides, I can simplify their ratio and turn it into the scale factor, which then I can use that in my proportion. So notice the only sides that have numbers are going to be the side down here at the bottom, TR, which is the first and the last letter, and it's going to match with the XZ, which is the first and the last letter here. So the length of TR is going to be 6 plus 6, and it's 12. And then the length of XZ is 8 plus 8, and it's 16. So now to get my scale factor, I'm doing right over left. So I'm doing XZ over TR. XZ is 16 and TR is 12. So the ratio, this is the ratio of the side lengths, which then turns into or is equal to the ratio of the scale factor. I can divide them both by 4, and my scale factor is 4 to 3. I'm now going to use my scale factor to find the altitude, which is PS. Now I'm going to go ahead and call PS X. just to make it easier to work with in my proportion. So what I'm going to be doing is setting up xz over tr is equal to py over ps, which is what I'm looking for. So let me fill that in. So this is the xz over tr, 4 over 3, is equal to py is 20, and I don't know ps. I'm now going to solve my proportion by doing the cross products. So 4 times x is equal to 3 times 20. 3 times 20 is 60. And now I can divide both sides by 4. And x equals 15, which I decided to substitute for ps. So the answer to the question, the altitude, ps, equals 15. To remember, when your figure is getting bigger, your scale factor is going to be a number greater than 1. Okay? If it's getting smaller, it's going to be less than 1. It'll be a fraction that's less than 1. So notice this one was greater than 1. It was an improper fraction. So that's how I could tell that from blue to red, it got bigger. So our first theorem is called the perimeter of similar polygons, which is what we've already demonstrated. So here it says if 2 polygons are similar, then their ratio of their perimeters is equal to the ratio of their corresponding side lengths, which again, remember, is also equal to the scale factor. And this is what we already did. So if you remember from example 1, when we were given those 2 figures, remember the one figure had a perimeter of 32. The other one had a perimeter of 40. That reduces the 4 to 5, which was also the scale factor. So this was the numbers from example 1. And we already demonstrated this theorem. So theorem 8.2, this one is called the areas of similar polygons. And it states that if 2 polygons are similar, then the ratio of their areas is equal to the squares of the ratios of their corresponding side length. So all you have to do is find one side length that you can put into a ratio, and then you square it. And then that's going to give you or enable you to calculate a missing area. And that's what we're going to do on the next slide. So for the last example, it says in the diagram, quadrilateral GHJK is similar to LMNP, and it wants us to find the area of that larger quadrilateral. So notice it's getting bigger. So I need to take the 2 side lengths that correspond and find the scale factor. So notice from my statement, I can see that PN here, the last 2 letters, are going to match with the last 2 letters here, the JK. So what I'm doing is taking PN, or NP, and putting it over JK to get my scale factor. This will simplify 3 to 1. This is my side length ratio. Or my corresponding side length ratio, because these are the corresponding sides, which is also equal to the scale factor. Now, it wanted area. What I'm going to have to do is take NP over JK, square it, and that's going to be equal to the area of LMNP over the area of JHJK. Everybody always forgets to square the scale factor. So whenever you're looking for a missing area, we need to take the scale factor or the corresponding side length ratio and square it. So I'm going to put in, it's going to be 21 over 7. I'm reducing it to 3 to 1. They gave me the area of the smaller quadrilateral. I don't know the larger. Remember, it's right over left. I'm going to square it, and then I'm going to cross multiply. So x times 1, 9 times 84, and x is equal to 756 meters squared. Now, if you didn't simplify the ratio, let's say instead you thought, I need to do 21 over 7 squared equals x over 84. You can do it this way, but look what happens to your numbers. It's a lot easier if you simplify the side length ratio first and then square it. Because then you would have gotten this, 37,044, and then have to divide that by 49. You still get the same answer. However, it's a lot easier to simplify the corresponding side length ratio first and then square it. So just remember, when you're looking for a missing area, you need to take the side length or the scale factor and square it before you use it in the proportion. And that is it for section 8.1.